Now let's move on to the cylindrical coordinate system. In cylindrical coordinate system, we have a cylindrical symmetry. So let's draw a cylinder to begin with. And the Cartesian coordinate system reference for this kind of a system is given as this. This is our x axis, this is y axis, and this is the z axis. So from the z axis is very important here. From the z axis, if we consider a point P on the surface of the cylinder, so the distance of that point P from the z axis, we will call that S, small s, and the position vector of that point P is given as R. We have, if we project R onto the xy plane, say the projection comes somewhere here, then that projection makes an angle with the x axis. That angle is phi, and the z component of that position vector is called z. So, z is also there in cylindrical coordinate system. So, we have x equals s cosine of phi, y equals s sine phi, and z equals z. The unit vectors can be given as s cap equals cosine phi x cap plus sine phi y cap, phi cap equals minus sine phi x cap plus cosine phi y cap, and z cap is certainly equal to z cap in Cartesian coordinate system. So, these are the unit vectors. Now, let us consider the infinitesimal displacement for line element. Along s direction, an infinitesimal displacement dls will be given as ds. Along the phi direction, dl phi can be given, because this is an angle, as s d phi, and along the z direction it is simple dz. So, the line element dl can be expressed as ds s cap plus s d phi phi cap plus dz z cap. It is simple. Let us consider the volume element. Volume element d tau would be given as multiplication of all these components, that is s ds d phi dz. We have to consider that S belongs to the range 0 to infinity, phi belongs to the range 0 to 2 pi, and z, just like the Cartesian coordinate system, belongs to the range minus infinity to infinity. Now, if we consider a surface element, let us draw a cylinder here, and if we consider a surface element on this cylindrical surface, then the distance is s from this axis, that is z axis, and we will rotate it by an element d phi. So, the distance that will travel, that it will travel along the surface is s d phi along the phi direction, and the other component would be z component. So, dz z cap, and this will give us s d phi dz, and the direction of this surface element would be s cap in this notation. So, this is a surface element on the cylindrical surface. We can find out other surface elements in a similar way. Let us move on to writing down the expressions for gradient, divergence, curl, and Laplacian. The expression for gradient is gradient of a scalar field T is given as del T del S S cap plus 1 over S del T del phi phi cap plus del T del Z Z cap. For divergence, of a vector field V in cylindrical coordinate system, the expression can be given as 1 over S del S S times Vs plus 1 over S del V phi del phi plus del Vz del Z. For curl, the expression is curl of a vector field V is given as 1 over S del Vz del phi minus del V phi del Z S cap plus del V S del Z minus del V Z del S phi cap plus 1 over S del S S V phi minus del V S del phi. This is along z cap. The Laplacian in cylindrical coordinate system acting on a scalar field T is given as 1 over S del S S del T del S plus 1 over S squared del 2T del phi 2 plus del 2T del Z2.